I welcome you to my YouTube channel. In this video, I am going to discuss the two JEE question from solution lesson. The topic that you are going to learn is how to calculate a molarity of a Fe plus 2 ion and HNO3. Let us see the first question. 20 ml of 0.02 molarity of K2Cr2O7 is used for the titration of 10 ml of Fe plus 2 in acidic medium. The molarity of Fe plus 2 you have to find out. The answer has to be expressed in terms of 10 power minus 2 molarity. So this question was asked in 2022 JEE examination. Let's try to fetch the data. So the given volume of K2Cr2O7 is 20 ml. That has to be converted into liters. 20 divided by 1000, you will get 0.020 liters. And the molarity of K2Cr2O7 is given as 0.02. So you have to write it. And the volume of a Fe plus 2 solution, volume is given as 10 ml. That also have to be converted into liters. Now the medium of this reaction is done in the presence of acid. To answer this question, the first thing what you need to do is you have to understand what actually happening between K2Cr2O7 and Fe plus 2. Then the next step, you will have to calculate how many number of moles of K2Cr2O7 present in the given quantity. 20 ml of 0.02 molarity will have how many number of moles. Then we need to find out how many number of moles of Fe plus 2 required. Using the balanced equation, I'm going to calculate the mole ratio. Then after finding the moles of Fe plus 2, using the number of mole, I'm going to calculate the molarity of Fe plus 2 solution, right? So now let's start. First, know the reaction which is taking place between Cr2O7 2 minus and Fe plus 2. So this is our balanced equation. Cr2O7 2 minus converted to Cr plus 3 and then Fe plus 2 converted to Fe plus 3. So for us, the most important thing is 1 mole of Cr2O7 needs 6 moles of Fe plus 2. Then let's calculate how many number of moles of K2Cr2O7 is present in 20 ml of 0.02 molarity. So to calculate the number of moles, what should I do? I'll have to multiply the moles molarity into volume. The molarity value is 0.02. Volume is given in terms of ml, so I'll have to convert it into liters. So by multiplying it, I have calculated 4 into 10 power minus 4 moles, right? Then I have to find out the mole ratio. Going back to the equation, I found that 1 mole of Cr2O7 minus needs 6 moles of Fe plus 2. So to find out the number of moles of Fe plus 2, I am going to multiply by 6 because I need 6 moles of Fe plus 2. So 6 into moles of K2Cr2O7. So 6 into number of moles of K2Cr2O7. We just found that 4 into 10 power minus 4. Multiplying that, you will get it 2.4 into 10 power minus 3 moles. Then this is what the moles required. So I am going to substitute in molarity formula. So molarity formula says mole by volume in terms of liters. So I'm going to substitute in terms of moles and then divided by the volume is given as 10 ml. So 10 divided by 1000, I will be getting 0.01. Simplifying this, I will be getting 0.24 molarity. But you'll have to express the answer in terms of 10 power minus 2. So the decimal point has to be kept 2 places to the right. Okay. This is your final answer. Now look at the second question. 800 ml of 0.5 molarity of nitric acid is going to be heated in a beaker. Its volume is reduced to half, and in this process 11.5 gram of nitric acid is evaporated. Now you are going to find out the molarity of remaining nitric acid present in the beaker. The answer has to be expressed in terms of 10 power minus 2. So this question was asked in JEE examination in 2022 exam. So let's try to fetch the data as given. The substance given here is nitric acid, HNO3. The molar mass is 63 gram per mole, and the initial volume is 800 ml. So that can be converted into liters, and then the initial molarity is given as zero point 0.5 molarity. Then final volume, you are heating it, and then the volume is reduced to half, and then you are getting 400 ml. So this 400 ml converted to liters, you are getting zero point 0.4 liters. Then in this process, 11.5 gram of nitric acid is evaporated. Okay, first of all, I'll have to calculate initial moles of HNO3. So in this given 800 ml of zero point 0.5 molarity, how many moles of HNO3 is there? Then I'll have to calculate in 11.5 gram of nitric acid, how many moles are there? And then using this, I can calculate what is the remaining mole. Then finally, I can calculate the molarity of 400 ml of nitric acid. So let us calculate initial moles of nitric acid. To calculate it, multiplying the molarity with the volume and zero point 0.5 into zero point 0.8, you will get zero point 0.4 moles. And I have to calculate how many moles of nitric acid is evaporated. So here the given mass is 11.5, and then dividing it by 63, I will calculate number of moles. Then I have to find out the difference. How many moles is still there in 400 ml of nitric acid? So this zero point 0.4 was the initial mole of nitric acid. From that, the number of moles of nitric acid which is evaporated is 0.1825, and the remaining mole is 0.2175 moles. Then we are going to calculate the molarity. So we know the number of moles of nitric acid is still there, and then we know the volume of nitric acid, so which is half of 800, so which means that 400 ml we have. Then converting it to liters, we get zero point 0.4. On simplification, we get the answer as 0.54375 molarity. But the answer has to be expressed in terms of 10 power minus 2. Then we'll have to move this decimal point to right side 2 places, right? So we, since we have 3, we can drop this, right? And then we get the answer as 54 into 10 power minus 2. I hope you understand. Thanks for watching. Please subscribe and like and share.